I wanted to start off today thinking about the problem of the consumer's problem in a little bit different light. And you guys had already seen part of this in, I believe, chapter 4, of kind of a different way of thinking about the problem. You guys, did you see the expenditure minimization problem as opposed to the utility maximization problem? So, two ways to think about the consumer optimization problem. Number one is the one we've been working on. We want to maximize utility that is some function of the outputs of goods. So we have good 1, good 2, good n. So all of the n goods that we consume, those are the quantities of goods. Subject to a budget constraint. Subject to a budget constraint. With a fixed income and prices of goods. Let's just call it PI. I put the little bar over there to signify that they're given to you, they're fixed until they change in the problem. So these are the exogenous variables, the outside variables that then we determine the endogenous variables. So when we crank through a solution, we're trying to solve for the optimal quantities given the prices of goods and our income. All right, so that's the process we went through before. Conceptually, we kind of thought of, there's my budget constraint, and I want to be on the highest indifference curve to maximize utility of x1 and x2. Just a little mini graph for you, right? Utility goes out as we go this way on higher indifference curves. An alternative thought to the same problem is kind of almost like looking through a mirror, is to minimize expenditure subject to a fixed amount of utility. Subject to utility being fixed at some level. So we say, I want to keep my utility equal to 100 units of satisfaction. What's the least amount of money that I can do to get there? And obviously I can't change prices, so we still have prices fixed for all of the goods that we have. But now I've got a indifference curve that looks like this, of the utility equal to 100, and I could be at any point along the indifference curve, A, B, C, or any other of the infinite number of points. And conceptually, what are we thinking about if our objective function now is the expenditures and we're trying to minimize it? I gave you this graph to kind of remember what we did with utility. What are we doing down here then? If we are trying to achieve this level of utility with the least amount of money possible, least amount of spending possible, how would you kind of graphically add that to the picture? Do you see it? We need to add a budget constraint.
Isn't it going to be the one closest to the
Good.
origin?
Closest to the origin while still doing what? Yep,
Yeah.
just being the tangent line at it. So we pull out the magic of the club. And given a certain price ratio for X and Y affects the slope, right? And then as I minimize expenditure, once the slope is fixed at a certain level, then what am I conceptually doing as I minimize expenditure? Like, say that's 1 point. So I could be at point C right there. Can I do better than point C? Yes. Why? What would I need to do to the golf club here to get to a better point? Like this? Jesse, what were you thinking? Shift it. How? That's right. How though? I want kind of precisely the shift. Like, does that mean it's like, that's kind of a shift in? Is that what's going on? Yeah. So can I change the slope? No. So it's a parallel shift, right? So it's a parallel shift in. So I'm spending less money if I go doop, like that. I'm spending less money if I do that. And then I keep going until it's tangent. And then I've taken away as much money as possible. I've spent the least amount of money possible for a given price ratio. I've minimized total expenditures. So we could kind of look at the problem like this. Let me just do a couple budget constraints here. So again, parallel shifts. Maybe it's that point, D, is the one that is the least amount of spending. And that tells me the optimal quantities of X1 and X2 that minimize expenditure. And so we're conceptually, graphically, we're shifting the budget line in because we're thinking of it as spending rather than income. All of the optimal condition remains the same. So the optimal maximizing condition is still where the marginal rate of substitution of X1 for X2, or 1 for 2, sometimes we do it that way, just is equal to the price ratio. The tangent point. So we get to the same spot we did before. So that's sometimes known as the dual to the consumer optimization problem, the dual problem. So it's like the mirror image, like we're really doing the same thing, we're just approaching it a little different. All right, questions on that? All right, so pull out your worksheets. We've got a little problem. We talked about Annika and her spending. And we were on to Cooper, right? All right, so how far did we get yesterday? Oh, we got all the way to E?
E was homework.
Oh, E was the homework, that's right, okay. So you tried to generate a demand curve, right? How'd it go?
There's no confusion at first. I read through the stuff I did in the book and it kind of sort of makes sense.
Kinda, sorta?
You had to look at the opposite of the
Yeah, and I think I've got maybe even a better way than the way the book did it. So, did you guys do okay on calculating the quantities? Well, I kind of gave them to you, but what was generally going on there? So, let me give a different stab at this. And you guys might want to copy this down. So on the vertical axis, we've got the theater tickets. And I want to put a graph that's stacked together such that the theater tickets line up with each other. And I'm not going to draw it perfectly to scale here, but I'll attempt to do something. The first point A was at 3 theater tickets, right? So we had 1, 2, and 3. Yeah. 1, 2, and 3. So I'm going to cheat a little bit here, or work backwards a little bit so that my graph lines up. So we had an indifference curve. Why do we just call it U1? So draw this picture first. So the lower graph is our normal demand curve space. Quantity of tickets, price of tickets. Upstairs is our utility quantity space of theater tickets, quantity of theater tickets, quantity of movies. All right, so this was our point A. Now our budget line had its shape, or its shape and slope, I guess, from the price ratio, which in this case was what on our initial budget constraint? What was the price of theater tickets? What was it? -5 was the slope. What was the price ratio though? If we take the price of tickets over the price of movies, since tickets are on the horizontal axis, what was the price of tickets? 50, right? So we had 50 over 10. So it's kind of helpful to think about it that way. That was our slope of 5. Had some negative signs in here for thinking about the slope. And so that maps down into this space this way. So if we come down here, that 3 is this 3. And we've got a $50 price tag. That's 1 point on the demand curve. So at a price of 50, I buy 3 tickets. Then the budget line rotates into, looks like 2.5. Let me go with a different color. And my quantity falls to 2. And so point B looks like that. The consumer re-optimizes based on a new budget because ticket prices went up to 100, but theater ticket or movie tickets didn't change. So theater went up to 100, theater tickets didn't change. What's that?
Is that one 80?
Oh, you're right, it was 80. 100 was the last one. So then we map that down into this space, and if we go up to 80, another point on the demand curve. And you can see already we're starting to, that's how we construct the demand curve, right? So the next rotation brought us into, let's go with black here. Brought us into here. And our new quantity dropped down to 1 ticket. That was our point C. My recommendation to you with this material is to draw big graphs. It'll help you. You can see how already even mine is getting kind of ugly up here. A lot of times we'll only do 2 shifts, not 3. So map this into this space. We got 100 and there's our demand curve. So we've got connect the dots, we've generated the demand from utility. And so that's kind of the underpinnings of utility and preferences and how we link the consumer's optimization problem to the quantities that they actually end up purchasing. All right, any last questions on that one? Okay, so I'm going to put something up on the board. Oh, this whole doggone thing is shut down. Maybe I'm not going to put it on the board. I'll put it on the board later. So let me just write down the details of the problem. You guys can get started thinking about it. So I want you to draw a graph with cakes on the vertical. We've got a problem with cakes and pies. Cakes on the vertical, pies on the horizontal. And Pablo has an income of 20. And let's see. The price of cakes is $1 and the price of pies is $1. So graph that budget line out and I will be right back. Because I didn't get this one all the way done here. Photocopy plan. Yeah, draw out that budget constraint. Draw it pretty nicely on the vertical and horizontal axis with your increments. Oh, sit down. Got it. I'm running to the class. I forgot to make copies this morning. Yeah. I will go run back too. Okay. The copier was down across the hall. All right, so here's the problem. Just wanted to get your juices flowing. And I screwed up the copier, so I got way more copies than I needed. Oh, did I only give you one? There we go.
Thank you.
Okay, so now you got the whole picture there. I just wanted to get at least your juices flowing with it, with the prices. So there's his picture. He's got those preferences. So why does the budget constraint rotate as it does in response to the increase in prices? So prices go from 1 to 2. First question is just meant to be kind of easy. Make sure we're all awake.
You can only buy half as many.
Okay, you can only buy half as many, so it think about those intercepts are kind of nice, right? That's our fallback is, okay, now I can only buy half as much because the price is doubled. So now, the good stuff here. Trace the diagram on a piece of paper, which I've already done for you. Separate the change in consumption of pies into the substitution effect and the income effect. So, we didn't talk about substitution and income effect yet. This is a new thing. In fact, we didn't cover this in principles class either. So this is super bonus material. What's that? Not this. No, I'm not. Well, no, I'm not. Not this particular. Oh, there's substitution and income effects. That's different for elasticities.
Right.
This is different. This is for utility analysis. So, but it's tied to that in a sense. So, price of what went down? Up? Pies. Price of pies goes down. Does Pavlo feel richer or poorer? Poorer, right? So prices went up, so in effect he kind of feels poorer. All right, so the idea of income and substitution effect is that there's these two forces that are going on when there's price changes. So if Pavlo didn't buy any pies anyway, an increase in the price of pies does nothing for him, right? But the fact that he's a pie buyer now makes him feel a little poorer. And so we can think about that in terms of his perception of income being taken away versus the substitution that would go on had he held his level of happiness constant, that internal trade-off that we've been talking about, which is along U1. So that is the kind of the dichotomy of the total movement of purchases. We're breaking down into an income effect and a substitution effect. Okay, so with Pavlo here, how can we get that? Well, what does income do when it changes? What does it do to the budget constraint? It shifts it in a parallel fashion, right? So we've got new prices, but we have the old amount. So now I want you to think about it a little differently. How could we compensate? How could we compensate Pavlo for his loss? So you don't have any control on prices, but maybe you're the government and you can just dish out some money, or your grandma. Oh, Pablo, I know you're a struggling college student who needs to eat their pies, so I tell you what, I'd like to keep you at your old level of happiness, and I'm just going to give you some money. How much money would Pablo need to be compensated for his loss from the decrease in price? No. You're on the right track for thinking, but think about the graph. You've got his happiness. Remember, we have kind of a special look that we actually know Pablo's preferences. So his preferences are given by these indifference curves, U1 and U2. How much money, and you can't give me an exact number, by the way, right now. I just want to think conceptually, what could be done to calculate the amount of money needed to compensate old Pablo here? How would you do it? What would you need to do? Again, conceptually, maybe thinking kind of golf clubby or moving things around. So we've got old prices, new prices. Pablo's utility went down to U2, right? The indifference curve is lower. And now Grandma wants to give Pablo an amount of money that will leave him with the same level of utility that he had before. Put him back to U1.
However much money he needs to buy 20 pies.
Okay, however much money he needs to buy 20 pies. That would be overcompensating him. Yeah, so that would be kind of overcompensating him, but good try.
Enough to shift his curve out
To be tangent to U1. Good, right? So if he's going out, let's see, I put the stupid screen down already. I wanted to do this in big style fashion here. If he wanted to go and make himself just as well off as before, the amount of money he would need is not the amount to buy 20. And I want to show that one because I'm glad you said that, Blake. If I can get this thing rolling here. Okay, document camera. What's going on? Oh, this power's not on. That's why. Come on, machine. Oh, got all kinds of delays this morning, don't we? Might be better off just drawing this thing. Well, you guys go ahead and start to do it. I think if you followed what Taylor said, we're going to give an amount of money so that we're going just tangent to that old indifference curve. There it is. Okay, I kind of like that it's not too bright. Might be able to see this online a little bit better. Okay, here we go. Ooh, this is golf club worthy. Okay. So, old prices, old utility, old happiness level. Price of pies goes up, that sucks for Pablo. He changes his behavior, by the way, right, and reduces his number of pies quite a bit. How much money would we need to give him to compensate? Blake thought, with a good thinking initially, what if I gave him enough to buy 20? Now, why is that giving too much? Let's explain Blake's answer that that's too much. What would Pablo be able to do? Okay, not the demand curve, but the budget constraint. So there's kind of a football region here, right? Which means that Pablo could be even happier. So that would make him too happy, is the point, right? Because he could be optimizing out here somewhere. The new tangent point with some indifference curve would lie way out here. So that's a little too much, and then where Taylor said to go is to the point where it's just indifferent to the old one, right? Because now we found a point that would make Pablo just as happy as he was before. Note, importantly, that he's not consuming the same amount of goods that he was before, but he's just as happy as he was before. So the movement from A to this point, let's call it C or whatever, is that a substitution effect or an income effect? Substitution. That's that internal substitution. Pablo, how much are you willing to trade to keep your happiness the same? I'm willing to substitute this many, I'll give up this many pies as long as I get this much cake. right? So that's the substitution effect, movement along that old indifference curve. Max?
So basically we're limiting the amount of pie that he has to give up. You know, cake stays together, we give pie. That's what
We're not limiting anything. We're just allowing him to re-optimize. So he re-optimized over here. The total effect of the change was moving from 16 to 14. And now we're kind of breaking that apart. We're saying, well, how much of that could be compensated? How much of that was really that income effect, like that pie made him feel worse off? So part of the effect was an income effect, which, by the way, then would be, if this is a 13 or something, so there's the income effect, dropping from here to here, and the substitution effect is going from 16 to here along the curve. So that's where we're going with this problem. So you guys work on it. I gave you basically the answer, but it's important for you to sit down and draw this now on your papers.
So would you have to keep your budget constraint, or like whatever, the same slope of that budget constraint move over to become changing, or?
Yes, because we're facing the new prices. So at the new prices, how much money do I have to give to compensate him for the loss in utility? Because all we're doing is we're going back to the old utility level. Okay, so draw a picture. I'll come around and see how you're doing.
Do you want us to trace it or just leave it on the same graph?
All on the same graph. The tracing part was actually to take it from the book. I already did that for you by making a photocopy. I would just work right on this one.
Oh.
I had you do that separately, but that's why, yeah, just work right on that paper. And then you got it all drawn nice. So basically, you just have to look for that tangent point. Okay. Try to, especially just for the early ones, maybe make that nice and tangent as close as possible. But you've got that concept.
I want it too steep or too flat.
So you were changing back the prices.
Yeah.
So the slope of the budget constraint is the new prices. So you need to shift this parallel. Give me your pencil. It's a little bit easier to see. You need to shift this parallel
Where it just touches the...
to where it's just kissing the old indifference curve.
Okay, I thought it had to be maintained with our
Nope.
y-intercept. It
Nope.
doesn't? Okay.
Not for this, because we're separating the two
Okay.
concepts of the income effect and substitution effect. Okay, good. Yep, trying to make that as parallel as
Good.
possible. Yep, that's fine. Now, wherever you think that you can kind of eyeball the
Does it
amount.
go all the way to the utility curve?
Okay, so this area doesn't mean anything.
Oh, it doesn't.
No. But the quantity is what we're focusing on. Yeah. So you're fine in that regard. Yep. That's parallel to this one because so the prices change and now we're going to come back to see how much income and then that breaks down the income effect and substitution effect. So it looks like you guys are on the right track here. So I want you to have in your notes the steps to follow because you're going to have some problems to work through with this too. And I'm going to have you do the starred problems in the chapter 5 material as your homework from over the weekend. So steps to follow with income effect and substitution effect. So, step number 1, and this is usually from a price change, by the way. Yes.
On this problem, what would the answer be when I asked which is larger, the substitution effect of the income or the
you want to go to the quantities. So where you're identifying the effect is the change on the quantities, whichever one was bigger. Let me write these steps down, and then actually that'll probably be one of the things at the end we'll do. So, so step number one, this is as you've got two places. Is so you've got, so I guess let's put the first step. Identify two equilibrium solutions with different prices. And you really want to focus in on, there's the old utility and the new utility. So let's call it UO and U1 for the indifference curves. Maybe I'll do old and new. All right, number two. You want to bring back the new prices to the old utility. So shift the new budget line to the old indifference curve. Shift the new budget line to the old indifference curve until tangent. Number three, mark those quantities. Number four, movement along the old indifference curve is the substitution effect. Which is the change in quantities. That's kind of addressing your question, Colby, on the change in quantity is what you're identifying. Because you can do this on the vertical axis too. Break down this part. So you're always looking at what's the income effect, what's the substitution effect. And then number five is the change in quantity from UO and new budget to the new indifference curve and new budget is the income effect. You'll have time to practice this a little bit, but this will hopefully, if you mark down this, I know this is confusing here. So for any of these changes, here's the old level of utility, the new, right? Take the new budget constraint, shift it back to the old level of utility, substitution effect, income effect.
Substitution effect where class was the income effect?
And so income effect, or substitution effect is this, which translates down here, substitution effect. And then the income effect is the rest of the distance that got you back to where you were.
Of point B.
Yeah. So on this thing, on this problem, however you guys drew it, you could do the same thing. There's the total effect. The substitution effect is this amount. Whatever, if you guys saw, some of you had like 13 or 14 or whatever you thought the number was. That's the substitution effect, the rest of it's the income effect. So the total effect is equal to the addition of the income and substitution effect. Here's the trick that you'll see in some problems. It's possible that with an inferior good, the income effect will overwhelm the substitution effect. The substitution effect is always a trade-off, but the income effect isn't necessarily always a trade-off, as you'll see in some problems.
So what's the total income effect? Do you have a number?
The total what?
Like what is
Oh, for this problem?
Yeah, for that problem.
Well, it would be, if you had 13 here, 13 minus 4 is 9.
Okay.
So 9 units, 9 pies was the income effect, and 3 pies was the substitution effect.
So it'd be inferior.
Yeah. An increase in income caused an increase in pies, so that's a normal good. Remember, if we go this way, it's like you're giving income. Take away income and you go down, that's a normal good. You lose your income, you buy less of something. You get more income, you buy more of something. So that's a normal good. All right. You'll have some fun working through those. So all the exercises in chapter 5 that have the asterisk. So it's just at the back of the chapter. Oh, that's a good question. I thought they did, but did you have a problem with that last time?
No, that should be.
I don't know. You assigned us actual numbers last time.
Okay, well, I'll just tell you what they are. Everybody ready? 3, 5, 11, 13, 14, and 20. That's 6 problems. Chapter 5.
So no learning curve.
Not yet. Yep. We're going to do this. I want you guys to hit some problems first this time. All right. Have a good. Oh!